Here is another example of an integral that would require u-substitution. Remember that we're going to let u be the radicand, the part that is under the radical. So in this case, u is equal to 2x plus 3. And then we're going to solve for x in terms of u. Inverse operation, so subtract 3, u minus 3 is equal to 2x. We'll divide both sides by 2. X is equal to u minus 3 divided by 2. You could also write that as u over 2 minus 3 over 2. Our next step is to differentiate the equation from step 2. But it also says that sometimes it's easier to do step 3 before step 2 and that these steps are interchangeable as far as the order that you do them in. So if you feel like this is easier to derive than this, they are the same amount of e's. This one just has fractions. But either way, you can derive either one because afterward you're going to have to solve for dx anyways. I'm going to derive this more complicated looking one. We're deriving u with respect to x, so u is a function of x, as you know. So the derivative with respect to x, I've rewritten this just so that we can see 1/2 is just the coefficient, and we're going to derive with respect to x because u is a function of x. The derivative with respect to x of x is 1. The derivative of u, 1/2 u with respect to x is 1/2 times the derivative of u with respect to x minus the derivative of a constant is 0. Then the step asks us to solve for dx. We need to get dx by itself. I think I can just multiply both sides by dx. And you get 1 times dx, which is just dx, is equal to 1/2 times du. And that is the amazing part of this notation, that we can actually treat it kind of like it's math, even though it's notation, and it works. All right, it's time to substitute u expressions for x expressions in the integral. There are actually some algebra steps that I can do first before I do this step of substituting u expressions. So I'm going to show you how to do that. 2x minus 1 over 2x plus 3 is to the power of 1/2. And to make it no longer a fraction, I'll say 2x minus 1 times 2x plus 3 to the power of negative 1/2 dx. Now we're going to do the step that substitutes u expressions for x expressions in the integral. Remember that u equals 2x plus 3. All right, we have u to the negative 1/2. Can I put u here? No. U is 2x plus 3. This is 2x minus 1. We will have to write x in terms of u, right? That's what we're doing. We're writing x in terms of u. So, do you have an equation that relates x and u? Yes, you do. Okay, x is equal to u over 2 minus 3 over 2. So this expression, instead of being 2x minus 1, will be 2 times x minus 1. And oh wait, what is x in terms of u? X in terms of u is u over 2 minus 3 over 2. What about dx? We can't integrate an entire expression in terms of u with a dx symbol at the end. We know dx in terms of du. dx is equal to 1/2 times du. So in place of dx, I will write 1/2 du. I have to make sure my integral is all in terms of u here. Let's do some algebraic simplification first. So if I distribute this 2, I'll end up having u minus 3 minus 1 times u to the negative 1/2. Oh, I have this times 1/2. Hey, guess what? If you're multiplying by a scalar, okay, by a number, then that number can be factored out of our integral only numbers can be factored out, never variables. So that, that's starting to shape up and look like an integral that perhaps we can solve. U to the negative 1/2 du. I still have a product here, and I don't know how to integrate products unless I can distribute it, which I can. 1/2 the integral of, this is u to the 1, or you could call this u to the 2/2. U to the 2/2 times u to the negative 1/2 is u to the positive 1/2. Remember, when you multiply the same base, you add the exponents. Minus 4u to the negative 1/2. All being integrated with respect to the variable u. I think we can separate our integral now, but don't forget that 1/2 will be multiplied by the entire thing, so I'll put 1/2 in a big bracket and now separate the integral to be the integral of u to the 1/2 du minus the integral of 4u to the negative 1/2 du. Hey, this 4 can be factored out of this integral. Okay, we would not put it in front of all of them. Now I can more easily integrate 1/2 times, again it's going to be times this whole piece, whatever we get out of these integrals. The integral of u to the 1/2 should be u to the 1/2 plus 1 is 3/2, and that is also my denominator, 3/2. Minus 4 times the integral of u to the negative 1/2. Negative 1/2 plus 1 is positive 1/2, so this would be u to the positive 1/2, and 1/2 would also be your denominator. It doesn't matter if you add c inside or add c outside, because distributing 1/2 times a constant is still a constant. Remember, c is just a constant. All right, let's simplify this algebraically so that we get the integral in terms of u, and then we will use that to find the integral in terms of x. Now, dividing by 3/2 is the same as multiplying by 2/3, so this is the same as 2u to the 3/2 over 3. Dividing by 1/2 is the same as multiplying by 2, so this would be 8u to the 1/2, of course, plus c. Now I will distribute my 1/2, and I get u to the 3/2 over 3 minus 4u to the 1/2 plus c. Yay, you found an integral. You just didn't exactly find the one they wanted us to find, because the one they wanted us to find is in terms of x. So we found an integral, we found the integral in terms of u, and now we need to substitute back in to get the integral in terms of x. So u is equal to 2x plus 3. 2x plus 3 and 2x plus 3. Now we have substituted, and this right here is our integral. This would be a completely AP appropriate answer because you have the integral and it's in terms of the variable x, which is what they originally asked for. But if this was a multiple choice question, your answer would most likely be more simplified than this. And it's really important to practice that simplification so that you don't look at your multiple choice answers and when you see one that is your answer, not actually recognize that it is the same as the answer you found. So that's very important. We're going to factor this expression. No matter what, for an indefinite integral, we always put plus c. So I'm going to leave the plus c out of all the factoring that I'm doing because plus c is just always tacked on to the end of an indefinite integral. Let's begin. I'm going to write this as 1/3, 2x plus 3 to the 3/2 minus 4, 2x plus 3 to the 1/2, and then of course we'll do plus c over here. So what can I factor out? I can factor out 2x plus 3, but I need to know to what power can I factor it out. 2x plus 3. You can factor out the power that is common with both of them. So 3/2 is larger than 1/2, but 1/2 goes into 3/2 and 1/2. So we will choose 1/2. We are multiplying this by 1/3 times 2x plus 3 to the 1. All right, now if I distributed that, I would get 1/3, 2x plus 3 to the 1/2 plus 1 is 3/2. That's a way we can check that. Minus 4 times 2x plus 3 to the 1/2. Oh, that's just 1, right? We factored that out. Simplify what you have inside of these brackets. Combine like terms, distribute, whatever you need to do. So I have 2x over 3 plus 3 over 3, which is 1, minus 4. This becomes 2x over 3 minus 3. We're still not quite done because they would not leave a fraction inside of a factored piece. So we're going to factor out this 1/3. If I factor out a 1/3 from this parentheses, I am dividing 2x over 3 by 1/3, which leaves me with 2x. I'm also dividing -3 by 1/3, which leaves me with -9. And you can check by distributing back and you will get this. 2x plus 3 all to the 1/2 plus c. So this is our indefinite integral in terms of the variable x in its more simplified form. More likely how you would see it on the multiple choice portion of the AP exam. Whereas free response, once you substitute back in your x's, you're done